doing 4.2, which is quadratics in standard form. Now, the only thing different between vertex form and standard form is finding the vertex. That's it. Okay? Everything else is exactly the same as yesterday. The only difference is finding the vertex. So that's where we're starting. They should be. Should be. All right, so first of all, I want to tell you about standard form. Standard form looks like this. Y equals ax squared plus bx plus c. This is standard form where a, b, and c are coefficients or numbers. To find the x value of the vertex, so to find x value of the vertex, use negative b over 2a. To find the y value of the vertex, plug x value into the equation. Okay, so let me show you exactly what I mean. If I have a quadratic in standard form, so y equals 2x squared plus 8x minus 5. That's in standard form. In standard form, this is my a value, this is my b value, and this is my c value. So to find x, I have to do negative b over 2a. So I have a negative b, which is 8, over 2 times a, which is 2. Not yet. Negative 8 divided by 4 is negative 2. So I know my x value of my vertex is negative 2. Now I take this negative 2 and plug it into my equation to find y. So y equals 2 times negative 2 squared plus 8 times negative 2 minus 5. So this is 8 minus 16 minus 5. So we get negative 13. So my vertex is at negative 2, negative 13. Oop. Once I have that, everything else is the same. Everything else is identical to yesterday except for this. Okay? Give me questions before I keep going. Yeah, you're going to have the first 6 are you're finding the vertex, x, symmetry, max or min, domain, and range. And then the last 6 you're graphing. And you don't have to say those other than the vertex. On the last 6, yes. Okay? So we're all clear now? All right. So with this in mind, let's do example number 1. Yes, everything's the same. All right, so example number 1, this is what I'm asking you to do for 1 through 6. I want you to state the vertex, axis of symmetry, max or min, domain, and range. Same thing from yesterday. Only difference is finding the vertex. So if I have y equals negative 2x squared plus 12x minus 7. So to find my vertex, I want to again remind you, this is A, this is B, and this is C. So x equals negative b, which is 12, over 2 times a, which is negative 2. Negative 12 divided by negative 4 is 3. So the x value of my vertex is 3. To find y, I take and plug that in. If you've noticed, the last few weeks in our warm-up, I've been having you plug in numbers, getting ready for today. Negative 2 times 3 squared plus 12 times 3 minus 7. So this is 9 times negative 2 is negative 18 plus 36 minus 7. So this is 18 minus 7, or 11. So my vertex is at 3, 11. So now, axis of symmetry, exactly like yesterday, x equals 3. My leading number, I have a negative in front. So that means this opens down. What's wrong, Julie? Oh. Okay, if I made a mistake, you just got to tell me. Okay. Okay, I wanted to clarify. All right. So, because this is negative in front, that means this is a maximum at y equals 11. Y equals 11. Then we do domain is negative infinity to infinity, and the range. Because it's a maximum, it starts at negative infinity and goes to 11, the y value. So again, the only thing different from yesterday is finding the vertex. Do we need another one? Yes, another one? Okay. Let's do example number 2, same thing. Example number 2. Find vertex. And we can just do axis of symmetry because everything else falls into place, I think, right? All right, so let's talk about the vertex and axis of symmetry. If I have y equals, how about negative x squared plus 6x minus 2. To find my vertex, remember this is my A, this is B, and this is C. So x equals negative b, which is 6, over 2 times a, which is negative 1. Negative 6 divided by negative 2, positive 3. All right. Now I have to find my y value by plugging 3 in for x. So I have a negative and then 3 in for x squared plus 6 times 3 minus 2. 3 squared is 9 times a negative is negative 9 plus 18 minus 2 is 7. I agree. All right, so my vertex is at 3, 7. That means my axis of symmetry is at x equals 3. Okay? The exam? Middle of next month. Okay. So this is all you had to do, right, is find those things for the first 6 problems. The last 6 problems we have to graph. So let's talk about that. To get the values, yes. Yep. Okay, guys. All right, next ones. Here's example number 3. All right. This is example 3, right? Okay. All right, I'm going to ask you to graph. And this time we are going to graph y equals, let's go x squared minus 4x plus 1. So the first thing we need to do is find our vertex. Same thing we did when we graphed yesterday. Got to find the vertex. So x equals negative b, so it's a negative negative 4 over 2 times 1. So it is 2. Very good. To get the y value, I have to plug 2 into this. So y equals 2 squared minus 4 times 2 plus 1. So that's 4 minus 8, which is negative 4, plus 1 is negative 3. So I have a vertex at 2, negative 3. So I'm going to go over 2 and down 1, 2, 3. Here's my vertex. My axis of symmetry is at x equals 2. That's where I have that dashed line right through that. Now, just like yesterday, I picked 2 points, preferably going into the direction of the y-axis. So I'm going to pick 1 and 0. So I'm going to plug 1 into this equation. 1 squared is 1. Minus 4 times 1 is negative 4, plus 1. I get negative 2. So I'm going to plot the point 1, negative 2. So I go 1 and down 2. Next, I'm going to plug in 0. I get 0 minus 0 plus 1 is 1. So at 0, I'm going to go up to 1. So now that I've plotted those 2 points, we reflect them. This one reflects to here, and this one reflects to here. And then we connect them. I missed my dot, but. So again, everything is the same as yesterday, except for how you find the vertex. Any question? No questions? We're better? Okay. So, huh? Okay.